Good day, geometry people. This is Mr. Heeren welcoming you back to 9.3. 9.2, part 1 and 2, dealt heavily with surface area. That's kind of what we were talking about in surface area with prisms and cylinders. So now we're going to take kind of a different look and look at pyramids and cones and start thinking about what does surface area of that look like. So if we consider a pyramid, this would be an example, and these are kind of the parts. So what I want to draw your attention to is slant height versus altitude, because those are going to be two distinct things that we need for surface areas, particularly the slant height here. Okay, the slant height here is going to become very, very handy because if I consider that all four sides of this are a triangle, my slant height, if I just look at the triangle, my slant height here in terms of a triangle would just represent my height, which when paired with my base means I can figure out that area, right? So remember, that's just going to be 1/2 base times height. So that's kind of what I'm working towards, okay? So base edge, lateral edge, vertex, slant height and altitude are going to be two of the bigger pieces we're looking at here. Okay, so if I consider this a pentagonal pyramid, that means that my base shape will simply be a pentagon, okay? And then if I unfold it, if I draw the net, it's going to look like that. So I end up with 5 triangles and 1 pentagon. Okay, so I do 5 triangles with 1 pentagon. L, if you notice the L here, the cursive L is short for slant height. All right, that's kind of what that represents. My slant height is going to be represented by L, which is going to be useful. Okay, so my lateral area of a pyramid, if I unfold this, in terms of words, what would I be looking at? Lateral area is just going to be just the triangles. Okay, so if I unfold this net, I consider that we'll call it a square. So that's going to be a triangle off of each side. So my lateral area is going to be just the triangles, okay? So the short answer, how do I do this? So the short answer is just going to be 1/2 times the perimeter times my slant height. Okay, so 1/2 perimeter times my slant height. So 1/2 big P times L. Okay, so perimeter literally means boom, 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 boom. All those, the perimeter of my base. Okay, so why does that work? So if I consider, another way to think about it would be, if I found the area of one triangle, I could just multiply it by 4 in this case. I can multiply it by how many triangles there are. That's fine. So what I'm looking at, though, is perimeter. So if this is one side, all right, so we just call it X. That would be 1/2 times X times L. That would give me the area of this triangle, right? So then I could multiply it by 4, which would be fine, okay? In this case, it'd be 4. But if it was a different shape, if it was something else, I would have to multiply it by 6. Or if it was something else, I could multiply it by 3. If it was a triangular pyramid, all of those. So all I'm doing is kind of moving this inside. Okay, all I'm doing is saying, however many sides there are, I'm multiplying by that one base. Okay, so this is like saying 1/2 times 4x times L. The 4 came because there's 4 sides. The x is one of these sides. All right, the x is one of these sides. So I'm just multiplying it by 4 times my slant height. That's it. That's my answer. Okay, so 4 times x, so 4x or one side, 4 times one side is going to give you my answer. Okay, so if I look, start off easy. That should be area, not areole. So this is a square. So 1/2 perimeter is going to be 16, 4, 4, 4, and 4, times my slant height, which is 6. So 16 times 6 is going to be 96 divided by 2 will give me 48. So my lateral area is going to be 48 inches squared. Now remember, that's just triangles, no base. Okay, that's just triangle, no base. So now let's take a look at this. I've got a hexagonal, so base is a hexagon, and it's a pyramid. The base edge is 9 centimeters. My slant height here would be 7 centimeters. Notice the slant height goes up the middle of one of the triangles, okay? I'm not going up one of the sides. I have to go right up the middle and be 90 degrees with that. So perimeter is going to be 9 times 6, okay? Hexagonal means 6, times my slant height of 7. So that becomes 1/2 times 54 times 7. So that's going to be 189 centimeters squared. And that's it. That's going to be my answer, okay? Now, will you have to do some work sometimes to find a slant height or a base edge? Yes, but this is just the general idea for now. So now surface area just kind of takes the lateral area and adds the area of the base. Okay, so your lateral area is just going to be still that 1/2 times perimeter times the slant height. But now you're going to add area of the base. And there's no real trick to put in there because you don't know what shape your base is. So that's multiplication plus big B for area of the base. Okay, so if I was going to cut this apart or draw this net out, so your lateral area covers those. Now you're adding the base to it, and all that together means your surface area. Okay, so there's 2 parts. You got to figure out the lateral area, then figure out your base, and then add them together. That's all you're doing. So now here, this is going to get a little trickier because the 16 is not my slant height. That is my altitude. I need to figure out my slant height. Well, if this whole thing is 12, then this is going to be 6. Okay? So let me back up. Surface area, I'm trying to do 1/2 times perimeter times slant height plus my area of the base. All right, right now I'm trying to figure out my slant height. Can I figure out my perimeter? Yes. 12, 12, 12, and 12 will be 48. I don't know my slant height. Can I figure out the area of a base? Yeah, it's a square, so 12 times 12. So now I need to figure this out, my slant height. Okay? How I can do that is this. This is a right triangle, and I know 2 sides. So I'm going to run through Pythagorean theorem because that thing shows up everywhere. And when I do that, I get 292 square root. So I get 17.09 equals C. So now I'm going to put that in. So 1/2 perimeter of that bottom is going to be 48. 12, 12, 12, and 12 times 17.09 plus 144. So I take that times 48 divided by 2 plus 144. I get approximately 554.11. That's what I get for an answer. Okay, so I took lateral area plus the area of the base. That's my answer. Notice it's different for a pyramid or a cone. I'm only taking one base. For prism and cylinder, I had two bases. Okay, so now a little bit different. A little different look. 1/2 times perimeter times slant height plus the area of the base. So 1/2 perimeter is going to be 40. 10 plus 10 plus 10 plus 10. Slant height is going to be 13. My area of the base, that shouldn't be equal. That should be plus. My apologies. That should be 10 times 10. So now this becomes 260. This becomes 100. So my answer should be 360 meters squared. Okay, here I'm given the slant height. On the previous one, I was not. I had to do some work to figure that out. This one is pretty straightforward, okay? As long as you start getting comfortable with, and this is what I would put on my note sheet too, is that 1/2 times perimeter times slant height plus the area of my base. Okay. So now this one gets a little messy because, 1/2 times perimeter times slant height plus the area of my base. This first part's not too bad. 1/2 perimeter, hexagonal means 6. So 6 times 5 times 8. That's 1/2, 30 times 8. So do all that and I end up with 120. The fun begins when I have to figure out the area of this base, because this is going back to late in Unit 8, where you had to figure out the area of a regular polygon. So this is where we kind of said, if you find the area of one triangle and then multiply it by 6. So 360 divided by 6 means that these are all 60. So that makes this 60. So if I cut it in half, that's 2.5, 30, 60, 90. Then I could do trig, or I could do 30, 60, 90. If I do 30, 60, 90, short side is 2.5, middle side is 2.5 times square root of 3, which is what I'm looking for. Okay, I'm looking for this middle side. So 2.5 times square root of 3 is 4.33. Okay, so that's my height, 4.33. So my triangle would be 5 times 4.33 divided by 2. So that's going to be 10.83. Then I multiply that by 6, because there's 6 triangles. So my area of my base becomes 64.95. So 120 plus my answer, the area of that whole thing is going to be 184.95 centimeters squared. And I rushed through this a little bit faster than I wanted to. Again, you could have done right triangle trig here. If I write this a little bigger, that's 30, that's 2.5. You're looking for that one. So I could have easily taken tangent of 30 equals 2.5 over my height and then solved it that way. I would have gotten the same answer, somewhere around 4.33. Okay, so that's all I'm doing. Make a note of this in your notes to kind of come back to it and look at it, because this one's a tough one. How do things change for a cone? The answer is your base is known. You know how to figure out the area of a circle. And then for lateral area, before it was lateral area was 1/2 times perimeter times slant height. The slant height stays the same, but what do we call the perimeter of a circle? What do we call my distance around a circle? We call that the circumference, right? So your circumference is 2 pi r times my slant height, right? So by doing a little bit of simplifying, this 2 and this 1/2 cancel out. So my lateral area ends up being just pi times the radius times the slant height. And my surface area becomes pi RL plus, how do you figure out the area of a circle? Pi r squared. So it just becomes pi r squared. So these two should go in your note sheet. Lateral area, pi RL. Surface area, pi RL plus pi r squared. So a waffle cone is 5.5 inches tall. The diameter is 2.5 inches. Find the lateral area. So we've got the waffle cone. I flipped it over. The diameter is 2.5. The height is 5.5. So I need the slant height. So my radius will be 1.25. Then I've got a right triangle, where I know this is 5.5, I know this is 1.25. So now a little bit of calculator mashing. And I get C to be 5.64. Again, I just kind of rushed through Pythagorean theorem there, just recognizing that 5.5 inches tall represents the straight height. A diameter of 2.5, cut that in half to get my radius. So now, pi times radius times slant height, pi, my radius will be 1.25, my slant height 5.64. And then again, just some calculator mashing, put all that into your calculator and see what you get. I get approximately 22.15 inches squared. And that's all I'm doing. That's it. That's it. Just pi times the radius, because that's all I want, the lateral area. Pi times radius times slant height. Surface area. Cone is 14.8. Slant height is 15. Good. We've given the slant height. So if the diameter is 14.8, my radius is just half that. So surface area means lateral area plus pi r squared plus the area of my circle. So that's going to be pi times 7.4 times 15 plus pi times 7.4 squared. So 7.4 times 15 will be 111 pi. 7.4 squared will be 54.76 pi. So in terms of pi, this would be 165.76 pi centimeters squared. And if I multiply that out, that's going to be approximately 520.75 centimeters squared. Okay, start here. I know my radius, I know my slant height, I know my radius there. So then after that, it just becomes plug and play. That's kind of it. So find the surface area of this cone. Slant height 2.2, radius 0.8. So again, pi times radius times slant height plus pi r squared. Pi times 0.8 times 2.2 plus pi times 0.8 squared. So 0.8 squared times is 0.64 pi. 0.8 times 2.2 will be 1.76 pi. Add that together, it becomes a total of 2.4 pi. So that would be in terms of pi. Okay, then multiply it out. total answer will be approximately 7.54 millimeters squared. Okay. Work through these. Make sure you understand where all these things are coming from or how to find them. Make sure you get going on the 9.3 work and then the 9.3 quizzes. Okay, and if your answers are a little bit different in the calculator, that's not too bad. If they're way off, be very careful about what you're entering and when. And I look forward to answering your questions. Thank you.